Let me introduce my first problem in this lecture, which is telling that in part A of the question, a block of mass m is to be raised by a rope from rest to rest through a height h. The rope can safely withstand a maximum tension of nmg, n being a multiplication factor. Find the shortest time in which the ascent can be made. And in part B of the question, if the block need not be at rest at height h, what would be the shortest time of ascent? We shall put this problem in difficulty level 2 and understand it first. Here is the block in question of mass m, raised vertically by a rope, presumably of negligible mass. And note carefully, they have said in the first part of the problem that the block has to be at rest at the starting point as well as at the end point of its ascent. That's important. So how do we do that? We raise the block by pulling this rope, pulling it with the help of this rope through a distance, a part of the journey with a constant acceleration of a, say the maximum possible acceleration, and then a second part of the ascent in which the block rises with a deceleration equal to g, numerically equal to free fall acceleration under the force of gravity, so that it eventually comes to rest at the final point of the journey also. So to understand this motion, the rise of this block, we can draw a velocity versus time graph for the block. This is v is plotted along this vertical axis, t along this horizontal axis. And as I said, in the first part of the ascent, the block is raised by pulling the rope with a constant acceleration of a, say. So this part of this graph is a linear one with a constant slope equal to the acceleration. This is the origin O, and the end point of this first part of journey, let it be called the point A on the graph. So you understand that at the end of this accelerated motion, the block attains the maximum velocity during its ascent. Let me call that as Vmax. And if the accelerated ascent takes place over a time of t1, then you drop a perpendicular from this point A onto this t-axis, and this point represents a time of t1, which means the accelerated journey happens over a time of t1. Suppose this straight line OA is making an angle of theta 1 with the t-axis. In that case, acceleration A is equal to tan theta 1 that you know from the chapters, the classes on kinematics. In second part of this ascent, this rope is allowed to become slack. There is no tension acting on this block, and therefore the block rises under the downward force of gravity, which means the block rises with a constant deceleration numerically equal to g, that is 9.80 meter per second square. So this part of motion graphically will be a straight line that goes from the maximum velocity up to a velocity of 0. Let me call this part of graph is AB, is also a straight line, and suppose this line makes an angle of theta 2 with the t-axis as shown. If the time of decelerated journey is taken to be t2, that is from A to B, in that case, this time here t is equal to t1 plus t2. So once again, over the part AB, the block is rising under the force of gravity alone. The force of gravity being a downward force, the block possesses a deceleration numerically equal to g, and therefore the velocity falls linearly to a value of 0. And the time of accelerated journey is taken to be t1, time of decelerated journey is taken to be t2, total time is taken to be t1 plus t2, and because of this motion, the block is at rest at the starting point as well as at the end point of its ascent. So this is the graphical way of understanding V versus T graph. Once we are here, we can look back at the kinematics we have learned earlier in theoretical classes, and the displacement of the block as it rises in a straight line, say along the y-axis, that displacement equal to h is graphically represented by the area under the graph OAB, that is the area of the triangle OAB, isn't it? So I can write down h is equal to the area of triangle OAB. This area is equal to half into height. Let me take this perpendicular foot to be the point C. So AC is the height into base, that is OB. This means H is equal to half into, AC is representing the Vmax, maximum velocity attained by the block during the rise. So it's half into Vmax multiplied by OB. OB represents the time of travel, total time of travel, that is T here only. So half into Vmax into T. That is my equation number 1. Now looking back at this graph once again, we can look at this triangle OAC. So let me write it here as well. The left side triangle OAC, the acceleration that is taken to be A is graphically represented by the slope of this line OA, isn't it? So A is equal to tan theta 1. In this triangle OAC, tan theta 1 is coming out to be perpendicular by base, which is AC divided by OC. But then AC represents Vmax and OC represents the time of accelerated travel, that is taken to be T1. So from here, I could write down that T1 is equal to Vmax by the acceleration, isn't it? Next, we look at the right side triangle, that is ACB. So looking at triangle ACB, once again, this is the motion with deceleration equal to g. Therefore, I can write down the deceleration g, that is given by the tangent of this angle theta 2. So this is tan theta 2. Once again, in the triangle, tan theta 2 is coming out to be perpendicular by base, that is AC by CD. And then AC is equal to Vmax. The length CB represents the time of decelerated journey that was taken to be T2 here. So is Vmax divided by T2. And from here, little bit of rearrangement giving me T2 is equal to Vmax by G. Adding up these two times, T1 and T2, you get the total time of travel. Therefore, we conclude from here, total time of ascent T is equal to T1 plus T2. Putting the values from above, that is Vmax by A plus Vmax by G. If I take Vmax as common, I get inside bracket 1 upon A plus 1 upon G, isn't it? So you have got time of travel totally, small t is equal to Vmax into 1 by A plus 1 by G, and therefore we might express the maximum velocity attained by the block during the ascent Vmax is equal to the total time of travel t divided by 1 upon A plus 1 upon G. Just come up to this. This is equation number 2 for me. We have already got total distance traveled, that is the height attained, H is equal to half into Vmax into T, equation number 1. And just now express Vmax in times of T only, equation number 2. So let's combine 1 and 2 to get an expression.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.